31. Which one produces the greatest number of ions when dissolved in water? I'm assuming we mean that this is very dilute. We're not having a super high concentration. This one would have 2 sodium ions and then a sulfate ion, and therefore that would be the most. The others each have, this is 2 pieces, ammonium and nitrate, sodium and chlorine, so that's just 2. Again, there's ammonium and then there's a chlorine, so that's 2. Sucrose would only have 1 particle. It's kind of related to the Van Hoff factor. You know, this would kind of be the limit for the Van Hoff factor. I might be 2, I might be 2, I might be a maximum of 2. This one, I's maximum would be 3. This one, the I would have a maximum value of 1. And of course, as the solution gets more and more and more and more concentrated, the Van Hoff factor might decrease. So maybe this becomes 2.6 if the concentration of the solution, I don't know, maybe if it's 0.10 molar, that's actually ridiculously concentrated. If it was, you know, maybe 0.010 molar, the Van Hoff factor drops a bit because it doesn't become quite as soluble. And if that's the case, I would be giving you the Van Hoff factor at a higher concentration. So unless I discuss the decrease in the Van Hoff factor, you could pretty much assume the maximum should hold. So just go with the maximums unless otherwise directed. 33, this one actually threw me the first time I read it. As the concentration of solute increases, so we're getting more solute, the freezing point would go down. The freezing point goes down, it decreases. And the vapor pressure, I wasn't thinking vapor pressure at first. That's why I got this wrong the first time I read it. The vapor pressure would also go down. Like we were saying, P is equal to chi P prime. And so because you have a solution, the pressure actually ends up decreasing also. 33, which of the following have the lowest freezing point? Well, this is what we were just talking about. When you have a solution, the temperature changes based on, here we go, the Van Hoff factor. You know, these are all the same molarity, 0.3, 0.3, 0.3, but D, that would probably have a Van Hoff factor close to 4. And so that one would have the greatest delta T because it would have 4 ions or 4 particles. 34, we have an aqueous solution. Delta T is 1.4 here. We don't know what I is, but we have a K for the equilibrium constant, 0.52. And the molality of the solution is 1.35. And when we solve for I, we're going to find that it is really darn close to 2. Let me find my paper here. Yeah, it is 2. So the only one that looks like it could be that compound is the potassium chloride. That's the only one with the I factor close to 2. Van Hoff factor close to 2. And then 35, what is the most likely Van Hoff factor for 0.01 molal calcium iodide? 0.01 is a rather concentrated solution, so it's not going to be the maximum. Here's the maximum. The maximum is 3. It's not going to be the maximum. It'd be something less than that, but pretty close. So I picked the 2.69. I'm not going to ask you a question like this on the test. I just wanted to put that out there to remind you that, you know, the Van Hoff factor is limited by the maximum, and it really starts to come into play as the solution gets more and more concentrated. The Van Hoff factor starts to get lower and lower, but you'll be given the Van Hoff factor. I won't ask you to guess it like it is in 35.